Welcome to the session. I am Dr. S. Anusha Kathyayani, Assistant Professor in Department of Chemistry, Institute of Aeronautical Engineering, Hyderabad. Today, we are going to discuss about the setting and hardening of cement. And we are going to focus on the introduction to the cement, the basic cement composition, and the process involved in the manufacturing of the cement, and what is setting and hardening, and what are the chemical reactions going to take place during this setting and hardening phase, and what are the reactions involved in this phase. We are going to say from day to day what are the reactions going to happen in this phase from this setting and hardening presentation. Coming to the cement, cement is defined as a binding agent which binds together with the other molecules, which may be the sand or rocks or bricks. It is used in the construction of buildings or these dams, etc. So it is used to bind various construction materials. It has a unique property which is called adhesive and cohesive properties. It is an essential ingredient of concrete and mortar. Concrete is nothing but a mixture of cement, sand and small chips of rocks. Cement is mixed with a water to form a paste, and that binds or aggregates with a sand or crushed rocks, etc., which due to this adhesive and cohesive properties, it bind together very hardly. It undergoes a phase called setting and hardening phase, which result in the fixed or rigid structure of the cement. Coming to the process involved in the cement manufacture, first the explosives are used for cement obtaining, because the limestones which is called the quarries, the explosives are used to collect the limestone from the quarries. So they are transported into a crusher where the macromolecules or the larger molecules are converted into the smaller molecules by using the crusher. Through the conveyor belt, it enters into the cement manufacturing unit, where the mixing will happen, because generally cement is nothing but a mixture of calcium aluminates or calcium silicates with iron ores, with some amount of iron ores. So they are mixed with a gypsum. So due to the according to the need or the application, this was mixed with the gypsum. So there the mixing will happen, the homogeneous mixture will obtained, then it enters into the ray mill, then it undergoes the filter and preheating. Here, to convert this calcium and magnesium, calcium silicate or magnesium silicate or calcium aluminates, so this has to be heated to remove the excess carbon dioxide. So here the preheating has to be done. Again it enters into the kiln, where it will undergo around 1400 degrees, from 500 to 1400 degrees centigrade. This mixture was heated. Then it enters into the cooler. Here we can see this is the sintering process. So through the conveyor belts, the homogeneous reaction enters into the kiln. This is a kiln. So it will rotary kiln. So it will rotate and it will heat the homogeneous mixture this way. So here all the carbon dioxide or the impurities present in the cement mixture got evaporated. So the mixture present in this kiln is called a clinker. So we will call it as the clinker. So what happens in the clinker? It will undergo the high temperature heating around 1400 to 1600 degrees centigrade, where the carbon dioxide or water molecules bonded with the limestone, everything will evaporate. So the finally obtained clinker is converted or diverted into the cooler kiln, where it was again the temperature was lowered here, so it was cooled. Then it was stored in a clinker silos. Then it was moved into the cement mill, where the very fine powder of cement was manufactured because of grinding. It may be through the ball milling or the silos. In the clinker silos, they are grinded into a very fine powder. Then it was transported through logistics. Then it is the final finished product of the cement. This is the rough idea of the cement manufacturing process. What is going to happen in this from starting quarry to the finished product. This is the process involved in the cement manufacturing. So then what is setting and hardening of cement? So then when cement when mixed with water, so before it is all about what is cement, we have known about what is cement and what is the process involved in the cement for the manufacture to get a rough idea. Now we are moving on to the once finished cement was formed or obtained, how it was going to the setting and hardening phase. Then when cement is mixed with water, it forms a paste, which is a plastic mass called cement paste. So when it was mixed with water, it forms a very gel-like or paste without sand. So it is called a cement paste. So during hydration reaction, the gel and crystalline products are formed. So when hydration means addition of water. So here addition, we are adding water molecule. So it undergoes hydration reaction where the gel and crystalline products are formed. The insoluble gels and the crystals have the ability to surround the inert materials like sand, bricks and crushed stones, etc. So the gel and the sand, these crystalline products forms, it is able to bind the materials present outside the cement paste, means which is a sand or crushed stones or bricks. So building blocks. So it forms a reaction between because it adhesive. It reacts with this and it have the ability to surround inert materials. So generally this process of solidification means converting the gel to solid. It involves two phases, which is called setting and then hardening. So the first thing is setting. First step involved here is setting, followed by the hardening step. So these are two different processes that occur due to the reaction between the water and the cementitious material. So generally the setting is the stiffening, means it is hardening. Stiffening of the fresh cement paste, which happens due to the initial gel or crystalline formation. So when the water hydration reaction takes place, means the cement is mixed with the water, it undergoes the hydration reaction. So the gel and the crystallines formed in the reaction causes the stiffening of the fresh cement. It becomes rigid. Then this is followed by a next step called hardening. Hardening is the development of strength, which happens due to the crystallization of the cement paste. Here first gel formation, here setting means it becomes a plastic mass or a plastic paste, which is called a cement paste due to the gel formation. So when it gives the stiff, means it gives the rigid structure. So coming to the hardening, it becomes very hard because because of development of strength. So this happens due to the crystallization of the cement paste, means it is converting from the gel form to the crystalline form, which gives the strength and becomes very hard material. So setting precedes hardening, means it happens after the setting. Hardening happens after the setting process, and both processes are gradual and continuous. Means once water is mixed, hydration takes place, the gel formation takes place, then it was on duration of time the gel is converted into the crystalline form, which becomes a very hard structure because of the increase in strength of the hardening paste. Generally, this setting and hardening results from the continuous reaction between the cementitious material and the water. So it undergoes a reaction. The cement undergoes a reaction with the water. So it is continuous, like gel formation, crystalline formation. So the rigid, it gives the stiffening first in the softening the setting process, and then it gives strength. Then it becomes very rigid, and the name itself showing like hardening. It becomes very hard. Hardening is development of strength. Why? Due to the crystallization of the cement present in the material. The process of solidification generally consists of 3 steps. So from this process, from the gel or the liquid paste to solid formation, it involves 3 steps. One is initial setting. Next one is dicalcium silicate and tricalcium silicate hydrolysis, and the final setting and hardening due to the formation of turbomonite gel. This is here dicalcium silicate and tricalcium silicate hydrolysis takes place in the second step, followed by turbomonite gel. So the final setting and hardening is due to this gel formation. So the setting describes the stiffening, means it becomes stiff because of gel formation of the fresh cement paste. Onset of rigidity occurs. Then the hardening begins after setting because it precedes Setting precedes hardening. So the hardening begins after setting, which indicates that a useful and measurable strength is developing, because it increasing its strength, which is a useful and measurable strength. The setting and hardening of cement is due to the formation of interlocking crystals between the reinforced by rigid gels formed by the hydration and hydrolysis of the constitutional compounds. Here it undergoes a series of reactions which is called hydrolysis and hydration process. They form the interlocking gels between these locking crystals are formed between the compounds which are reinforced by rigid gel formations. These gels are formed by again hydrolysis and hydration and hydrolysis reaction. So we are going to see what are the differences between the setting and hardening of cement. So the setting is the term used to describe the stiffening of the cement paste, whereas hardening, it refers to the gain of strength as of a set of cement paste. This is stiffening process and this is the gaining the strength of the cement. It refers to a change from a fluid to a rigid state. It refers to a formation of a solid mass possessing good compressive strength. Here this is fluid to liquid, means liquid to solid. Here solid mass to hard solid, means rigid solid. Here the setting of a cement starts after 30 minutes from the instant when water is added to the cement and compacted within 10 hours. Means when it is added water, the cement is mixed with water, the reaction called hydration takes place when instant water is added to the cement and it completes within 10 hours. The process of hardening of cement continues for more than 1 year. So it is a long process. It continues even more than 1 year. To know the setting of cement, initial setting time test and final setting time test are conducted. So to know the setting of a cement, generally these two tests, which is called the initial setting time test and the final setting time test are conducted, which gives the setting time of a cement. So before adding water and after stiffening the water, which is called the final setting time, are conducted to know the setting time of a particular cement paste. Here, to know the hardening of cement, compressive strength test is conducted. In order to know the hardening, this test, which is called compressive strength test, is conducted to know the hardening of a cement. These are the two tests conducted to know the setting time and the hardening time of a particular cement. So we have known what is the gel formation and how gels are formed, like interlocking crystals, and then how it is converted into the crystalline, which gives the strength to the cement. So we are going to see in detail the reactions involved in setting and hardening of a cement. So coming to the reactions involved in setting and hardening of a cement, in general, day 1, when the cement is mixed with water, means the initial reaction between the cement and the water, which results in the cement paste. At first, hydration of the tricalcium aluminate, means 3CaO aluminate, Al2O3. So here the tricalcium aluminate will plus water, which is called the hydration. Any molecules react with the water called the hydration. If the water molecules was removed, then it is called the hydrolysis. Hydro means water, lysis means breakdown. Means now we are going to add, then it is called the hydration process. Here the tricalcium aluminate reacts with the water molecules, which undergoes hydrolysis reaction. Then it was go and attach to the calcium aluminate. Here hydrated tricalcium aluminate, plus it is an exothermic reaction which gives the energy. Here 880 kilojoules per kg energy was released, means it is an exothermic reaction, it produces heat. Here in the day 1, it involves this takes place rapidly within 1 day and the paste becomes quite rigid within a short time, which is known as the initial set or flash set. Here the tricalcium aluminates react with the water molecules, results in the hydrated tricalcium aluminate, which is a crystalline structure, which is an exothermic reaction which gives 880 kilojoules per kg of energy. So in order to retard this rapid hydration of this tricalcium aluminate, which is called a flash set or initial set, the gypsum is added during the grinding of cement clickers. So in order to improve this property of setting, this gypsum was generally added in the manufacturing of this cement. So here what happens, the gypsum reacts with the C3A, which is called tricalcium aluminate, to give insoluble calcium sulfoaluminate complex, which does not possess hydrating property and retards early setting of cement. Generally, the purpose of adding gypsum to the cement is this. Because of this property, the gypsum is added. What happens? This gypsum reacts and gives insoluble calcium sulfoaluminate complex. In the manufacturing process of cement, gypsum is added because to improve or to make early of the setting time. Here, because the gypsum is added because it reacts with the tricalcium aluminate to form a calcium sulfoaluminate complex which does not possess the hydrating property. So, and retards the early cement setting time. So, here the tricalcium aluminate plus, which is called a gypsum. This is calcium sulfate, gives rise to calcium sulfoaluminate. So when it was mixed with gypsum, it gives in the calcium sulfoaluminate complex which does not possess this hydrating property. So that is all about the day 1 reactions involved. What happens? The tricalcium aluminate reacts with the water, gives rise to hydrated tricalcium aluminate. So which reacts with the gypsum results in the formation of this calcium alumino sulfur complex, which doesn't have the hydrating property. So coming to the day 2 to day 7, so the after hydration of the C3 or C3S, C3A is tricalcium aluminate, or this is gypsum complex which is called tricalcium sulfur complex, begins to hydrate to give turberminate gel. It gives rise to turberminate gel and crystalline calcium hydroxide. So this is responsible for the development of initial setting of initial strength of cement. So what happens? This reacts with this C3A or this calcium complex reacts with these water molecules. Again, it undergoes hydration process, results in the formation of turberminate gel, and which is a crystalline structure. With calcium hydroxide is crystalline, and again it is also called an exothermic reaction which results in the yield of 500 kilojoules per kg of energy. So again, this is when the cement is mixed with the gypsum, it results in the formation of a tricalcium sulfoaluminate complex which reacts with the water molecules, results in the formation of this complex, and which is called turberminate gel or 3-calcium hydroxide, which is also a crystalline structure. So this gypsum is added according to the application of the cement. So in general, the gypsum purpose is to initiate to decrease the setting time because it doesn't have the hydration property. So what happens when it reacts with the tricalcium aluminate, it forms a sulfoaluminate complex which doesn't have the hydration property. It results in the easy setting time or the early setting time of the cement. Here, it does not contribute much to the strength of a cement. Here, the hydration of C3S gets completed within, suppose if gypsum is added, it gets completed within 7 days. It does not contribute to the much strength of the cement because it is involved only in the setting. In setting stage, only stiffening happens. In coming to the hardening stage, it increases its strength due to the crystalline formation. This gypsum doesn't involve in the hardening step. Coming to the day 7 to day 28, here dicalcium silicates reacts with water very slowly and gets completed in 7 to 28 days. Here the reaction involved is here dicalcium silicates plus water molecules hydrolysis reaction gives rise to this turberminate gel and calcium hydroxide which is a crystalline, which is also an exothermic reaction which gives 250 kilojoules per kg energy. Here when it is mixed with this gypsum, then This is dicalcium sulfoaluminate complex plus 4 water molecules gives rise to this tobermanate gel and calcium hydroxide, which is a crystalline. Here, so we are going to see both the reactions which with the addition of with the sulfur complex and without sulfur complex, which is called calcium sulfate silicates, dicalcium silicates. The increase in strength between 7 to 28 days is due to the formation of this tobermanate gel and crystalline of calcium hydroxide of both C2S and C3S, means dicalcium sulfur complex and tricalcium sulfur complex, which gives this crystalline which is resulted from the formation. This crystalline calcium hydroxide is resulted from the reaction between the water molecules of dicalcium silicates, sulfates, and this tricalcium sulfur complexes. So the hydration of this tetracalcium aluminoferrate takes place initially, the hardening takes place finally through the crystallization process along with the C2S. Here the 4 calcium oxide aluminate and here generally the cement is a mixture of calcium aluminates, calcium silicates and iron ores. So it contains iron traces, amount of iron in it. Here iron oxide Fe2O3 plus reacts with water molecules, results in the crystalline structure of calcium oxide aluminates, which is hydrated. This is hydrated tricalcium aluminates plus this calcium oxide iron hydrated calcium iron plus exothermic reaction of 420 kilojoules per kg. Here this shortcut here C4 tetracalcium iron tricalcium aluminoferrite plus water molecules gives rise to this C3A tricalcium hydrated aluminates. This is hydrated tricalcium aluminates. So here this is the reaction involved in between the tetracalcium. It is here dicalcium, tricalcium and tetracalcium aluminates undergoes these reactions. Thus, the final setting and hardening of cement is due to the formation of this tobermanate gel plus the crystallization of calcium hydroxide from the C3S or C4S and hydrated tricalcium aluminate. So the hardening of the cement is mainly due to the formation of this tobermanate gel formation and crystallization of calcium hydroxide from this tricalcium sulfoaluminate complex or tricalcium aluminates or the tetracalcium aluminates, and also due to the hydrated tricalcium aluminate formation. It gives the very rigid structure to the cement, which is very hard. So this hardening process involves these reaction steps. This happens from 1 to 28 days and it will continue for almost for the 1 year. So this continuous process takes place and gives the rigid and hard strength to the cement. In this, the crystallization of the calcium hydroxide and the gel, this hydrated tricalcium aluminate formation gives the strength to the cement, which increases the hardening process in the cement. This is about the setting and hardening of the cement and the reactions involved in hardening process of the cement. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.